Welcome to Breaking News to Trading Moves. Today we're looking at a strategic move in the high-performance computing space. It's an announcement that deals with software, really the plumbing of the system, but it has some broad commercial implications for a lot of companies.
It absolutely does. And the headline really centers on Nvidia, the company trading under the ticker NVDA, and a recent acquisition they've made.
Right.
And this is one of those acquisitions that, on the surface, it might not grab your attention like a new chip announcement would, but it involves some really essential infrastructure, the kind of stuff that underpins this whole explosion in AI training and large-scale computing.
Okay, so let's establish the basics right away for everyone listening. Nvidia has acquired a company called SchedMD.
That's right, SchedMD.
Now, we all know Nvidia as a hardware giant. They make the high-end silicon. SchedMD, though, that's probably a new name for many. They're the company behind something called Slurm. So for our audience who might be more focused on the hardware side of things, what exactly is Slurm, and why does a hardware company even care about it?
That is the perfect question to start with. So Slurm isn't a product you go and buy in a box. It's more of a utility. You could almost call it the beating heart of these really large-scale compute environments. It's an extremely popular open-source workload manager. And to define its role, let's just say when you hear about these giant AI models being trained for weeks or even months.
Right, across thousands of machines?
Exactly. Those computations, they're running across a cluster of thousands of interconnected machines. Slurm. Slurm is a mission control for that entire cluster.
So if I'm picturing an AI data center as this massive, high-speed automated factory, is Slurm kind of the operations manager, the one walking the floor, telling every machine what to do and when?
That's a really good analogy, yeah. Slurm is that critical management layer. It's the plumbing, like you said, that dictates the flow of work inside these colossal environments. Its main job is arbitration.
Arbitration?
Yes. It schedules and manages all the compute jobs across these huge clusters, which can have thousands of GPUs, CPUs, tons of memory. And it allocates those resources with just meticulous precision.
Can we get a little more specific on resource allocation? What does that actually mean in this context?
Sure. So when a data scientist submits a really complex training job, they don't manually go and tell thousands of GPUs what to do one by one. That would be impossible.
Of course.
Instead, they submit the job to Slurm. And then Slurm takes over. It decides where that job runs, which computers are free, which ones have the right setup. It decides when the job runs, fitting it into the queue. And crucially, it decides how much of the available hardware, how many GPUs or compute nodes that job gets. It's all about ensuring fairness and maximizing utilization.
So if that management layer is bad or inefficient, what happens to these clusters that cost millions or even billions of dollars?
Oh, it's a disaster. If you don't have an efficient and robust workload manager like Slurm, those incredibly expensive clusters just fall into operational disarray. You basically suffer from three big problems. First is congestion. Jobs just pile up because the scheduler can't figure out the best way to run them. Second is underutilization.
The expensive hardware just sits there.
Exactly. GPUs sit idle between jobs because the scheduler is too slow to assign the next task. It's a condition often called node idling or fragmentation.
I see.
And the third thing is just resource waste, where jobs are given more hardware than they actually need, which starves other jobs in the queue. For these big data centers where utilization rates are everything, that kind of inefficiency is just enormously costly.
That makes the financial side of it very, very clear. If I have $100 million worth of hardware, every single minute that it sits idle or, is only used at 50% capacity because of software fiction, that's just lost money.
It's lost potential revenue. It's wasted capital expenditure. You've got it. And the scale of modern AI workloads, it just makes the problem even worse. As these jobs get more and more distributed with more processors all talking to each other, the complexity of managing all that just explodes.
And Slurm is the tool that's become the standard for handling that.
It really has. It's grown into the industry standard, especially places like universities, national labs, and now more and more with the commercial AI cloud providers. A big part of that is because it's open source and very flexible.
Okay, so now that we get the critical role Slurm plays in just making things run efficiently, let's talk about the strategy here. Why would Nvidia, a company that sells proprietary hardware and tightly controlled software like CUD, why would they buy and then commit to keeping an open source vendor-neutral tool? What's the real motive?
Well, NVIDIA's public statements on this were very clear, and I think strategically quite smart. They said Slurm will stay open source, and vendor neutral.
They're not going to lock it down.
No. They plan to keep investing in its development, even aggressively. This move isn't about creating some proprietary lockdown NVIDIA Slurm. It's about optimization.
Yeah.
Optimization at a very, very foundational level.
That just feels a little counterintuitive for a company that is so good at creating vendor lock-in with its proprietary tech. Why keep this key piece of infrastructure free and open?
Because the end goal for NVIDIA isn't to sell a scheduler. The end goal is to sell the maximum possible number of GPUs at the highest possible margin.
Ah, okay.
And the best way to do that is to ensure maximum performance and the absolute easiest path to deployment on their hardware. If NVIDIA can pour their own resources into SchedMD, they can make Slurm more efficient, they can integrate it better than anyone else with their own CDA software stack, and they can streamline its operations specifically for their GPU clusters using their own interconnects like NVLink and InfiniBand.
So they're using the open source nature of the tool as an accelerant for their proprietary hardware sales. They're perfecting the user experience on the back end.
Precisely. Think of it from the customer's point of view. If a cluster operator can get, say, 98% utilization of their NVIDIA hardware right out of the box, just because the scheduling software has been flawlessly tuned by the hardware maker itself,
They're going to choose the NVIDIA stack every single time.
every time, the efficiency becomes the moat, not the proprietary nature of the scheduler. The fact that it just works better is the selling point.
Okay, so let's get into the details of that operational payoff. What does that kind of deep vertical integration between the hardware and the scheduler actually deliver?
It leads directly to those two things that any large-scale compute provider dreams of: a verifiable increase in GPU utilization and a substantial reduction in idle time, or what you might call queue latency.
Right.
If you, as a customer, are spending billions to build out a GPU cluster, minimizing the time those GPUs are sitting unused it's the most important factor in your return on investment, period.
So if NVIDIA can come in and say their version of Slurm can improve resource backfilling by, what, 15%?
Right, something like that. Backfilling is just quickly assigning a new job the moment the old one finishes. If they can guarantee a 15% improvement, that translates into tens of millions of dollars saved or earned across a large data center over a year.
So the thesis is that this highly optimized software stack makes NVIDIA-based infrastructure just fundamentally more attractive and easier to deploy when you're operating at a massive scale.
That's it, exactly. This isn't just about silicon anymore. It's another careful step for NVIDIA in building this wider, stickier ecosystem that goes way beyond the core chips. By buying the key piece of middleware, the scheduler, and then using its open source status, they maintain trust. They prevent competitors from fragmenting the market, and they ensure their hardware operates with the absolute minimum amount of friction.
And friction reduction is a powerful tool.
It's an incredibly powerful competitive instrument in the infrastructure market.
It's clear this move really strengthens NVIDIA's position. So let's move directly into the analysis of the market reaction. Let's start with the winners, the segments, and the companies that really stand to benefit from this enhanced integrated approach.
The immediate beneficiaries are pretty clear. It's the companies who build, sell, and use the infrastructure that is so heavily reliant on NVIDIA's technology. The improved scheduling and cluster efficiency that comes from this, it just acts as a powerful accelerant for that whole ecosystem.
Okay, so let's start with the core group, the NVIDIA GPU ecosystem and the AI server builders. Who are we talking about here specifically, and how does better software, like a scheduler, actually lead to faster sales of physical hardware?
The whole rationale comes down to CapEx velocity. That's the speed at which companies are spending on new equipment.
Okay.
If the software layer, Slurm in this case, works demonstrably better and integrates seamlessly, it lowers the time and the technical risk it takes to deploy new GPU clusters. It also speeds up the upgrades of existing ones.
So when the systems are just easier to run.
When they're easier to run, when they give you higher utilization rates and they offer a lower total cost of ownership because there's less friction, the demand for the underlying hardware just accelerates. So the core entity benefiting, of course, is NVIDIA itself, ticker NVDA.
Right. But what about the hardware integrators, the companies actually assembling these specialized machines?
There, we should look closely at Super Microcomputer, that's ticker SMCI, Dell Technologies, ticker DELL, and Hewlett-Packard Enterprise, which is HPE.
And these are the companies providing the physical servers, the racks, the cooling.
Everything. The physical housing for these massive GPU clusters. For them, any operational improvement driven by better software is a strong commercial tailwind.
Can you break down that mechanism? How does that tailwind actually work for a company like HPE or Dell?
Sure. These companies sell large, very complex systems. It often requires a lot of service and deep integration work. Their customers, cloud providers, big corporations, research labs, they really demand two things above all else: reliability and guaranteed utilization.
They want to know the thing they're buying is going to work and work hard.
Exactly. So if NVIDIA comes in and perfects the management software layer, it validates the entire investment decision for the buyer. And easier deployment means the customer starts to see a return on their investment faster. And that confidence encourages faster build-out cycles.
So better software reduces the hesitation in the C-suite and actually drives physical hardware sales faster than they might have gone otherwise. It's de-risking the CapEx decision.
You've nailed it. Imagine you're the CIO of a company, and you need to guarantee 95% utilization on a multi-million-dollar cluster. If NVIDIA can essentially guarantee that they've optimized Slurm to help you hit that target reliably, you're going to be much quicker to purchase the next generation of servers from SMCI or HPE.
Because you have confidence in the model.
You have confidence in the utilization model, and you have a reduced integration burden. Efficiency doesn't just save money. It creates velocity in the purchase and deployment cycle, and that benefits everyone who is selling the underlying iron.
That paints a very clear picture of the hardware acceleration. So let's move to the second group of winners, the AI, cloud, and GPU capacity providers. These are the companies renting out the compute power.
Yes, and this is a very direct link. Slurm is already widely used by these companies. They really have no choice. They have to manage and assign massive, simultaneous AI training and inference workloads across these big, shared, multi-tenant clusters.
So when you go and rent a machine for an hour of training from one of these cloud providers, you expect that hour to be perfectly used.
Down to the second. And for providers like Amazon or Microsoft, how does NVIDIA owning SchedMD translate into a benefit?
Yeah.
Well, it's twofold. There's internal operational cost reduction, and then there's external customer satisfaction.
Okay, let's start with the internal part.
Internally, having deep support and explicit improvements in Slurm just means these giants can manage their vast fleets of NVIDIA hardware more economically. Less human intervention is needed, hardware utilization rates go up. Externally, that translates directly into lower friction for their customers.
Can you illustrate what you mean by lower friction?
Sure. Think about the experience of actually launching a job on one of these services. A customer who rents a large GPU cluster, they need seamless workload scaling, especially when their job is running right next to a competitor's on the same hardware.
Right.
If the underlying scheduler Slurm is impeccable, the customer experiences less time waiting in the queue, more predictable resource provisioning, and fewer dropped or rescheduled jobs. Minimizing that friction, maximizing that efficiency, it makes providers like Amazon, ticker AMZN, Microsoft, ticker MSST, and Alphabet, ticker GOOGL, it just makes them more competitive and more reliable for their highest demand AI users.
Stability leads to customer loyalty.
It translates directly into customer loyalty and revenue retention in what is a very high-stakes, highly contested rental market.
Now, the context specifically mentions a customer, CoreWeave. Why is their situation noteworthy?
CoreWeave, ticker CRWV, is a great example here because they're noted as an existing customer of SchedMD, and they are a specialized provider. They don't do everything like the big hyperscalers. They focus entirely on offering massive, elastic GPU compute capacity that's optimized specifically for AI workloads.
So they compete directly with the big guys on this one specific thing.
They do. And for a company whose entire value proposition is built on high utilization, low latency, and easy access to large GPU pools, having the original developer of their scheduling software now owned by their hardware maker, that is a distinct operational advantage.
It suggests a really close working relationship, I would think. It would allow CoreWeave to tune their environment almost perfectly with the chips and the workload manager.
That's exactly what it suggests. They get the closest possible feedback loop between the hardware, the operating environment, and that crucial scheduling layer. This allows them to shave milliseconds off resource allocation times, maximize their cluster packing density, and really cement their edge in a niche that demands absolute peak performance.
Okay, that makes sense. Now for the third category of beneficiaries, the data center networking and interconnect providers. This feels like a classic second-order effect, but a really important one. I wouldn't have immediately thought that an acquisition focused on a scheduling algorithm would directly boost companies selling physical cables and switches.
It is, but it's an extrapolation of the efficiency argument. And this is where that vertical integration really starts to put pressure on the rest of the supply chain.
How so?
Well, if you successfully solve the operational bottleneck, meaning You make the GPU clusters so efficient that the GPUs are actively computing 98% of the time instead of, say, 80%. You radically increase the need for the system to move data between those processors at extremely high speed.
The faster the processing happens, the more data you need to feed it, and the faster you need to get the results out.
Precisely. The whole point of the scheduler acquisition is to eliminate the compute bottleneck. But when you do that, you inevitably run headlong into the data movement bottleneck. The more compute capacity you successfully maximize, the greater the scaling needs become across the entire system. And that requires more spending on high-speed networking, on switching hardware, on interconnect technology. The data transfer infrastructure has to keep up.
So we're talking about the difference between a system that's often pausing and waiting for instructions and one that's just running flat out, constantly demanding more data.
That is the practical difference. A cluster running at 98% utilization generates vastly more network traffic than one running at 75%. To maintain that high utilization, the network has to be ultra-fast and resilient. And that forces large-scale investment in high-bandwidth, low-latency components.
So which companies are positioned to benefit from that increased spending on connectivity?
Here we're looking at companies like Arista Networks, ticker ANET, Broadcom, ticker AVGO, and Marvell Technology, ticker MRVL. Arista and Broadcom are critical players in that high-speed Ethernet switching and connectivity space that really forms the backbone of modern hyperscale data centers. Arista is focused on the networking equipment itself, while Broadcom provides the critical chips, the ASICs that power that equipment.
And Marvell's role in this?
Marvell is deeply involved in specialized infrastructure components, custom silicon, particularly high-speed optical and copper interconnects. They provide the physical layer technology, the stuff that's crucial for moving data between server racks and even within the nodes themselves.
So every piece of the data-moving puzzle has to be upgraded.
It has to be. The optics, the Ethernet switches, the proprietary interconnects, all of it must be upgraded to handle the load of a continuously running, highly utilized cluster.
So the ability to maximize compute capacity with better scheduling creates an immediate and unavoidable need to upgrade the data transfer infrastructure.
It's an unavoidable corollary. You solve the compute utilization problem and you run straight into the next constraint, which is data movement. And the companies that provide the components to solve that second constraint are direct commercial beneficiaries of the original software acquisition. That's the ecosystem effect in action.
That gives us a really clear picture of the entities that gain an advantage. So now let's pivot to the other side of this. Where is this move applying competitive pressure? Who are the companies facing challenges from this consolidation?
Well, this consolidation of the hardware and the critical software layers, it creates pressure primarily for rival hardware vendors and providers of competing proprietary software. Nvidia is, well, they're deepening the moat around their ecosystem, making it that much harder for others to gain a foothold.
Let's start with the rival accelerator and alternative platform vendors. Who are the primary companies facing this strengthened Nvidia position, and what does the scheduler acquisition specifically do to challenge them?
The key players here are Advanced Micro Devices, that's ticker AMD, Intel Corporation, ticker INTC, and ARM Holdings, ticker ARM.
Right.
All three of them offer alternative hardware architectures that compete directly with NVIDIA's GPU systems. They're all aiming for a piece of that massive AI and HPC market.
So why does NVIDIA buying a piece of open source software materially affect AMD's ability to sell their Instinct chips, for example, or Intel's push with their Gaudi accelerators?
By acquiring SchedMD, NVIDIA is effectively tightening its grip on the entire technology stack. They have the hardware, they have the primary software layer with CUDA, and now they have a key component of the cluster management software with Slurm.
And that creates a perfectly tuned reference architecture that's hard to replicate.
It's extremely difficult to replicate piecemeal, yes.
So is the problem that AMD or Intel can't run Slurm, or is it that they can't make Slurm run as well as NVIDIA can on NVIDIA hardware?
It's the latter. That's the crucial distinction. Because Slurm is open source, anyone can use it. But NVIDIA now effectively controls the source code. They can dedicate an army of engineers to perform deep proprietary tuning and integration specifically for their own next-generation hardware.
And that tuning goes deep.
Oh, yeah. It includes ensuring Slurm seamlessly interacts with their low-level drivers, their memory allocations, the network topography that's unique to the NVIDIA architecture. That level of tuning is incredibly difficult for a competitor to match when they don't have that internal knowledge of the architecture and, frankly, the resources to maintain an equivalent effort on the open source code.
So when a big organization or a cloud provider is deciding on an architecture, they're not just weighing the raw specs of a chip, they're weighing the total system friction.
Exactly. They're looking for standardization and maximum efficiency right out of the box. If Slurm, the most popular open source scheduler, is now perfectly tuned for Nvidia hardware, then using a competing accelerator from AMD or Intel suddenly introduces a complexity cost,
A risk.
a risk. Buyers might hesitate because they face the risk of optimization gaps, poor utilization rates, or just complex integration headaches if they deviate from that fully tuned Nvidia stack. It raises the switching costs, not with a literal hardware lock, but with a practical operational friction lock.
So in essence, NVIDIA is improving the overall product experience for its hardware, which makes the raw chip performance of its rivals less relevant if that chip is harder to integrate.
It's a software barrier to entry. It makes it much harder for competing accelerators to secure those big standardized deployments because the ecosystem preference just leans so heavily toward the fully optimized end-to-end NVIDIA experience.
And that's a challenge for a company like ARM as well.
It is. For ARM, which licenses architectures, the challenge is similar. Their partners, who build chips based on ARM designs, now have to find ways to integrate their silicon with the dominant scheduler, which is now functionally controlled by their primary rival.
Okay. Let's move on to the second category of companies feeling the pressure: the proprietary HPC scheduler and workload management vendors. This seems like a textbook conflict of business models: paid software versus a highly optimized, free alternative.
It is a direct and forceful challenge. NVIDIA's commitment to keeping Slurm vendor neutral and highly supported, it directly threatens the business model of existing paid proprietary scheduling platforms.
And which companies are we watching here? What are their main products that overlap with Slurm?
We're tracking International Business Machines, ticker IBM, and Oracle, ticker ORCL. Both of these companies have very deep roots in traditional enterprise and government HPC environments, where proprietary software has been the norm for a long time.
Can you give a specific example of that competitive overlap?
Sure, the context explicitly points to IBM's product, Spectrum LSF. LSF stands for Load Sharing Facility. It's a comprehensive HPC workload manager and job scheduler. It does essentially the same thing as Slurm. It manages queues, allocates resources, and ensures fault tolerance, but it's sold as a proprietary paid solution. It requires licenses and dedicated support contracts.
Right. And Oracle has similar tools.
They do, yes. They offer workload management tools that target similar enterprise HPC environments.
So if NVIDIA, the undisputed market leader in AI hardware, is now pouring resources into perfecting a free, open-source alternative, how does that really challenge IBM's Spectrum LSF offering and its long-term viability?
The challenge is intense. Organizations now have to perform a really rigorous cost-benefit analysis. They have to ask themselves, why should we keep paying for the LSF license and support, which can run into millions for a large enterprise, when the hardware vendor itself is making the open-source alternative the easiest, most efficient, and best-supported solution for our massive new GPU investments?
It puts IBM and Oracle in a very tough spot. They have to deliver value that goes far, far beyond what the free, optimized Slurm can offer.
They do. They have to justify that premium price tag. And while Spectrum LSF might have some advanced features for, say, specific legacy system integration or complex policy management, the general trend in the high-growth AI compute market is towards standardization and ease of deployment.
And it becomes harder for them to compete on performance.
It becomes much harder. As the demands of AI require deeper integration with the underlying hardware, a layer NVIDIA now controls, it becomes increasingly difficult for a proprietary scheduler to compete on performance without NVIDIA's direct cooperation. And that puts a lot of pressure on the pricing and the market share of these traditional paid platforms.
That makes the direct competitive pressure very clear. So let's talk about the final category, which is identified as a second-order watch list: paid AI platform and MLOps vendors. This feels a bit broader, more structural.
It is a more subtle pressure, but it's rooted in NVIDIA's larger strategic posture. This acquisition isn't happening in a vacuum. It's part of a pattern. NVIDIA is clearly pushing harder to promote and perfect open-source components across the entire AI stack.
Not just infrastructure software like Slurm.
Not just infrastructure,
Yeah.
but also increasingly sophisticated open models and tools for development and operations.
So how does that increased availability of capable open source tools affect the vendors who are selling comprehensive paid AI platforms?
The core commercial pressure comes from the idea of good enough functionality becoming widely available and free. And not just free, but maintained and perfected by the most capitalized company in the sector.
Right.
So companies whose business model relies on providing these paid proprietary platforms, what are often called MLOps platforms, they face a challenge in maintaining their pricing power and their growth rates.
And who are the specific entities that are listed on this watch list?
We are tracking C3.ai, that's ticker AI, Snowflake, ticker SNOW, and Palantir Technologies, ticker PLTR.
Okay, let's focus on the mechanics of that. How does an improved Slurm or NVIDIA's general open source push create challenges for a company like Snowflake, for example? They're focused on data warehousing and AI applications, not just scheduling.
That's true. These companies offer platforms that are much broader than just job scheduling, but what they are selling is ease of use, integration, and a packaged, robust experience for developing and deploying AI models.
A kind of all-in-one solution.
Exactly. But if the underlying infrastructure tools, the operating systems, the schedulers, the data loaders, the foundational models, if all of those things become robust, scalable, and supremely easy to use because they're being perfected by the industry standard setter, Nvidia, then a critical segment of customers may just opt for self-assembly.
Meaning customers with the right technical expertise could decide to just build their own AI stacks using these highly tuned free components and bypass the need for an expensive, all-encompassing paid platform.
That is the dynamic at play. If the basic building blocks of the AI workflow, including cluster management via Slurm, become free and highly optimized by the ecosystem's leader, then the proprietary platforms have to constantly justify their premium value add. They have to prove they offer superior domain expertise, or better governance, or integrations that are genuinely impossible to replicate with the open tools.
So if the plumbing works flawlessly for free and the open source models are highly competitive, the premium charged by these paid software layers could see some pressure.
It could see pressure on pricing, or maybe a deceleration in growth, particularly within their most technically sophisticated customer segments. This is especially true for companies like C3.ai and Palantir, whose value often lies in integrating complex software workflows.
Right.
When the complexity of that foundational infrastructure layer is reduced by optimized free software like Slurm, their starting point for providing value, it shrinks. They're now competing against the free and optimized default, which forces them to innovate much faster on the application and domain expertise layer to maintain their premium pricing. It's a long-term systemic pressure.
This has been a very detailed exploration of the market consequences, all the way from immediate hardware sales to these longer-term software platform competitors. So, to summarize the main takeaway for our listeners, this acquisition seems to be about far more than just buying a technology company.
Absolutely. The Nvidia acquisition of SchedMD really demonstrates a continued, clear, strategic focus on software integration as the primary competitive differentiator in the race for AI compute dominance. It's just not enough anymore to have the fastest raw hardware.
The new imperative is making the whole system work together.
The whole system, the hardware, the interconnects, the software stack, and the scheduler, all of it, operating flawlessly as a single, unified entity. This move directly benefits those who provide the infrastructure and hardware that support NVIDIA's ecosystem, while posing tangible challenges to their hardware rivals and to the traditional proprietary software vendors who just can't match that level of integration.
That brings us to our final thought. We've spent this time analyzing the players based on this move. What's the fundamental concept you want the listener to take away from this discussion about how AI infrastructure and market competition are evolving?
The primary metric that dictates success in scaling large-scale AI operations is changing. It's moving away from simple benchmarks. It's not the raw speed of a single processor that guarantees market victory anymore, or even its theoretical performance.
So what is it?
The true determinant of competitive advantage is the verified efficiency of the total system. How effectively all the components, from the silicon to the interconnects to a workload scheduler like Slurm, work together as a single, highly tuned operational machine, one that minimizes downtime and maximizes throughput. System efficiency. That's the modern battleground where billions are being won or lost.
That is a crucial and clarifying insight. Thank you for guiding us through this analysis. This conversation is not financial advice, nor is it a recommendation to buy or sell any security. This content reflects solely the opinion of the author.